The next reaction we're going to look at is the reaction of alcohols with sodium. As you can see from the equation on the board, if you add ethanol to sodium, then it reacts in a similar way to how sodium reacts when it reacts with water. It forms a salt. In this case, the salt is called sodium ethoxide, and it forms hydrogen gas. Which salt it makes will depend on which alcohol you add to it. So, for example, if you add sodium to methanol, the products will be sodium methoxide and hydrogen. Sodium methoxide and hydrogen. If you add sodium and propanol, you'll get sodium propoxide and hydrogen. Likewise, if you change the alkali metal, for example, to potassium, and you did potassium and ethanol, you would get potassium ethoxide and hydrogen. You do not need to be able to write symbol equations for this, but I have given one there for you, just in case you're interested. Okay, so all that has happened in this reaction is you have replaced the hydrogen, the final hydrogen on the ethanol, with a sodium atom, and your product is hydrogen gas, which has the formula H2. Okay, so that's why it needs to be balanced as well, because H2, you need 2 hydrogen atoms to leave. Therefore, you need 2 hydrogen atoms from the ethanol to be replaced, so you need 2 sodiums as well. Okay, so you need to be aware of the word equations for these reactions. Okay, I'm now going to compare the way these different substances react. Okay, and I'm going to add sodium to some ethanol. At the same time, I'm going to add it to some water, so you can compare the reaction of sodium and water with the reaction of sodium and ethanol. And so I've got 2 approximately equal size pieces of sodium. Now, as you can see, they're much smaller pieces of sodium than you have probably used when your teacher has demonstrated this before. That's because I'm doing it in a beaker rather than in a large dish like you have seen before. I'm doing that because I don't want to waste a lot of ethanol by filling a big dish full of ethanol. Obviously, it's fine to fill that large dish with water because we can just get water out of the tap, but I don't want to waste equipment, so I'm doing it in a little beaker. That means I've also got to add less sodium because otherwise it's potentially hazardous. Okay, so into the ethanol and into the water go my 2 pieces of sodium. Okay, and we can see straight away that the sodium in water is fizzing very rapidly, as we have seen before. It's racing across the surface of the water in a ball on the left, whereas with an alcohol, you can see the reaction of sodium with alcohol on the right. Okay, there is bubbling happening, but it's not very vigorous. Excuse me. So there are bubbles of hydrogen being produced, but it's not a particularly vigorous reaction. All of the sodium now in the water reaction has reacted, and therefore the reaction has finished, whereas over here we can see that my sodium is still bubbling away. Okay, very, very lightly. There's not much effervescence happening. In both cases, the product that is being made is an alkali. So if we were to test these with universal indicator, they would both be a dark blue or purple in colour. So in the case of sodium and water, we know that our product should be sodium hydroxide and that is a strong alkali. And as predicted, we get that blue colour that shows us that a strong alkali has been made. Okay, Also, in the case of the sodium ethoxide, which is the product of the reaction of an alcohol, ethanol, and sodium, okay, that's also a strong alkali, and so we should find that that also turns blue or purple when you add universal indicator to it. So you cannot tell the difference between these two reactions by testing them with the universal indicator. That won't work because they both form alkalis. Okay. However, you can tell the difference between them by observing the fact that one bubbles much more vigorously than the other when they react. You can see there's that bit of sodium is still going around and around in the alcohol. It still hasn't completely reacted. It's still bubbling away.